Got the function y equals root x over 1 plus x. Some values are tabulated, and we're asked to use the trapezium rule with the values in the table to find an estimate for this integral. So there are 5 points being used, 5 coordinates. Actually, this means it's going to be 4 intervals. Here's the general form of the trapezium rule. I'm going to write it down when n is 4. Just still the general case of a function, but when n is 4. So y0 plus y4, and then 2 lots of all the others. Okay, just very quickly going to talk about this. So I've got some sort of function, and I want to estimate the area between 2 points. I split it up into these 4 equal sections, draw straight lines, which will create trapezia. It won't be exact because there'll be little gaps. It's quite flat. I didn't kind of exaggerate anything. Um, and then we're going to find these. And when you add up all these trapezia, so you only include this side length and this side length once, that's the y0 and the y4, but when you add the trapezia up, you include these twice because they belong to 2 trapezia. So that's where this 2 comes from. It's a very quick explanation, but just kind of want to go back over the formula a little bit. So therefore, for us, we've got the integral from 0.5 to 2.5 of root x over 1 plus x is going to be approximately a half. For us, height is actually 0.5 because that's what it's going up by every time. That is the width of our trapeziums. And then we're just going to substitute these values in. This is y0, this is y4, and everything in between. So 0.5774. We're not having to tabulate this ourselves. Plus 0.8452. And plus 2 lots, the rest 0.7071 plus 7746. Sorry, I've kind of spilled over onto 3 lines. Not great mathematically to do this. I should have started on a new line, but okay. You got the idea. Okay, and then substitute this into our calculator. So half is just the same as 0.5. Just do it really carefully. Right, close the bracket for what we're timesing by 2, close the bracket for what we're timesing by a half times 0.5, gives us an answer of 1.5049. Give our answers to 3 significant figures, so 1.50. It's actually not a terrible idea to just very quickly work out the exact value by putting the actual function in. A calculator can deal with that. Okay, and it's actually using something like the trapezium rule, but with probably lots of strips so it can guarantee accuracy, or as many as it needs to guarantee accuracy. And then that's actually the exact answer. So we've been pretty confident that we've done that right. Use our answer to part A to deduce an estimate for this integral. It's very, very similar, but there's a 9 there. So what we can do actually is write it as um, integral of 0.5 to 2.5 and take the 9 out of the square root. So it's going to be root 9 or 3. And you can even bring the 3 outside the integral because constants you can just take outside. we do the integral and then times by 3 at the end. It's actually the same answer as if you kept it in. So that means it's just going to be our answer from previous, that 1 point. By the way, do not use the rounded version because when we times through by 3, that 4 is going to come into play. 1.5049 times by 3. We don't get 4.5, we get 4.51. I'm actually going to write best practice, write the whole thing down, and then it doesn't say, but it's probably going to expect us to round it to 3 significant figures, which I will now do. Okay, and actually the question's quite nice. It says, given that it's this, so now we can actually, this validates our answer to part A and part B. Comment on the accuracy to our answer. So this, I didn't like stump me, but I thought like, what is it actually looking for? But it's basically asking us to say that it is accurate. But what I think is good to say is like how accurate it is as well. So I wrote answer to B is actually correct to 1 decimal place because they both become 4.5 to 1 decimal place, whereas the 2 decimal places are not quite the same. So that's us sort of saying, it is accurate to 1 decimal place. It's not like obviously perfect. So as long as you write something along those lines, the mark scheme did just say like, you can say, yes, the answer is accurate, but I'd say this is like the textbook answer, a good one to write down. Well done.